Hello everyone, and welcome back to the next devlog of Astro, a zero-gravity multiplayer first-person shooter set in an asteroid. It's crazy that 2 weeks have already gone by since devlog 0, and I have a lot of progress to show you guys. The first thing I needed to do ASAP was upgrade the game to Unreal Engine 5. If you haven't heard, UE5 is the next major update to the Unreal Engine, which is the game engine I'm using, so I definitely wanted to move the game to this version to access all the cool new features. Unfortunately, my game did not exactly like this, and there were several problems, especially with the Asteroid when I switched projects. After straightening things out, I got to work trying to improve the looks of the Asteroid, as this is something I had promised to do in the last devlog. With the old Asteroid, I was simply picking a random color for each triangle, but in the new look, I wanted to take advantage of UV mapping. If you don't know, UVs are a way to texture a 3D object by using a simple 2D image. Essentially, an artist will unwrap their 3D model by hand or with the help of unwrapping algorithms, and then draw on the image to give color to their model. Since the asteroid is generated procedurally, I can't do this UV unwrapping process in advance, since I don't know the shape of the asteroid in advance. So my first approach was to create my own UV unwrapping algorithm to unwrap the asteroid on the fly, and then create a texture using more procedural generation, and fill it with colors. After plenty of failed attempts, I realized that my algorithm wasn't wrong, I was just creating the texture at too low of a resolution. See, for an asteroid this size, to have fine grained detail up close, I would need to generate a texture on the order of 10,000 by 10,000 pixels. That means 100 billion iterations for each pixel in the screen. As you can guess, this is completely infeasible, and would take roughly 30 seconds to a minute to finish computing. Even after my computer finished creating the texture, it would cause so much lag that the game was unplayable. My second attempt was to scrap textures and go straight to shaders. See, with shaders, I don't need to pre-build a texture. I can simply choose the color for each pixel during every frame. But I only care about the pixels on screen, not for every single triangle, which was the case of the previous method. Several iterations later, I was getting some awesome looking results, and I was excited to finally see my asteroid coming into its full glory. My next goal was to straighten out the weapon system in the game. A big problem in first-person shooters is that the game world is not perfectly in sync for all users. Everyone playing the game is seeing their teammates and their enemies in a position that's slightly behind the actual position. This is due to latency, or ping. The higher your ping, the farther behind you see your enemies. What this means is that when I shoot my gun aimed perfectly at your center of gravity, you actually have already moved 4 feet away from where you were previously standing, and my shot shouldn't hit you, right? Obviously this is a big problem, since even with a ping as low as 10, hitting a headshot on an enemy moving at a jogging pace becomes almost impossible. To fix this, most first-person shooters create a mechanism called lag compensation. Lag comp allows a player to say, hey, I shot my gun at this exact time, and then the server will look back at where all the players were standing and see if the bullet hit anyone. I definitely needed a system like this, since I intend to have very high-paced movement in my game, meaning without lag comp you probably wouldn't be hitting anything. Also, if you're wondering why we can't just let the player tell the server when they shoot someone, this would allow players to hack the game and just tell the server that they shot everyone. We want a system that is server authoritative. Unfortunately, Unreal Engine does not make this easy for you at all. There are 3 big factors as to why lag comp is a challenge. First, there's no synchronized time between the user and the server. So if I tell the server, hey, I shot my gun at X seconds since the game started, the server will think I meant a completely different time, since the server starts their game clock way ahead of the client. Secondly, it's not just the enemy positions which are behind, but the client is actually ahead of the server. See, I'm using client-side prediction to move the player ahead in time, so that not only are all the enemies 1 times your ping in the past, but you are 1 times your ping in the future. On top of all this, even if I was able to accurately sync server and client clocks, communicate time differences, and find the exact moment when the player pulled their trigger and where all the enemies were, I would still miss half the time on a moving target, because what the player sees on their screen is actually an interpolated position of their enemies between the last 2 states sent from the server. If you're thinking it seems like the player would hit their target a lot, but the bullet wouldn't register, Look no further than blanks in Fortnite. Fortunately, I thought of a way to completely cheat the system and achieve perfect lag compensation while still protecting against hackers. So in my lag comp system, when a player shoots an enemy on their screen, they send a message to the server saying, "Hey, I shot this enemy, and when I shot him, I was standing here and he was standing there." At first, you're probably thinking, this seems easy to cheat, just lie to the server about who you shot. The key is that the server will then validate the request. First, I check that if any point in the last 2 seconds, the player was standing where they said they were. If not, the shot doesn't count. Next, I check that if any point in the last 2 seconds, the enemy was standing where the player says they were. Finally, I check that given those conditions, the shot from the player's position would in fact hit the enemy. If all of these are true, I validate the shot. Otherwise, it gets rejected. And if the client lies by too big of a margin, they get kicked. I like this system a lot because it means that as long as you're not hacking and you have a sub 1000 ping, when you shoot with crosshairs on the enemy, the shot is 100% guaranteed to register. With these two big tasks out of the way, I got around to implementing some additional features to improve the appearance of my game for the next playtest. I chalked up some horrible but basic animations, grabbed a free rigged skin off the internet, added a melee, and finished with some UI improvements. While trying to do a bit of visual improvement on the death system, I realized that I should probably implement ragdolls, since those are usually fun in first-person shooters. And that's when I discovered the beauty of zero-gravity ragdolls. Lastly, I playtested the game this weekend with some friends, and we had a bunch of solid rounds. If you're looking at the map and players, and wondering why it seems so much worse than before, I had to seriously scale down the graphics for performance reasons, since my friends were playing on non-gaming laptops. Then it kinda hit me that my game was extremely unperformant. I was struggling to pull 30 frames, even when I sucked the graphics dry of detail. Even on my brother's gaming computer, when I turned on the intended graphics, I was barely hitting 60 FPS. Unfortunately, the combination of real-time mesh generation and complex shaders meant the game was extremely unplayable. This is something I hadn't even considered during development, but now was becoming painfully obvious. I mean, this shader has over 1,000 instructions, and I'm not even satisfied with calling this the finished look of the Asteroid. All of this led me to the conclusion that I am no longer pursuing procedurally generated maps. While I've held dearly to this feature, and I think it makes the game unique and exciting, at the end of the day, it is just that, a feature, whereas bad graphics are an absolute deal breaker. Going forward, I'll be hand designing the Asteroid, as well as other completely new maps, rich with props, high-res lighting, and texturing. Most importantly, I will have much higher performance. While this is a major setback to development, I think it's definitely the right choice. So that means I have a lot of work to do between now and the next devlog. So I better get back to Visual Studio. Thanks for watching and stay tuned for future updates.
Stop sitting outside the map.
I'm playtesting. You are far away. No, come on.
Press the messages, people.
No. I'm gonna make an all chat though pretty soon.
Because I'm send hateful things.
I'm not gonna have
On stream
Can you please do voice chat or like proximity chat?
proximity.
proximity.
Death chat. Death chat. Please do proximity chat.